This is a fuel pellet. It's a ceramic cylinder about the size of a pencil eraser, composed of enriched uranium dioxide, compressed to 95% of theoretical density. It weighs 7 grams. In your hand, it's warm, not from radioactivity, which is minimal at this stage, but from the ambient heat of the processing facility where it was manufactured. This single pellet contains the energy equivalent of 17,000 cubic feet of natural gas, 1,780 pounds of coal, or 149 gallons of oil. There are 264 of these pellets in a single fuel rod. There are 264 fuel rods in a single fuel assembly. There are 157 fuel assemblies in a single reactor core. And there are 440 commercial nuclear reactors operating worldwide, consuming approximately 67,500 metric tons of uranium fuel annually. Here's what should concern you. 44% of the world's enriched uranium, the processed fuel that actually goes into reactors, comes from a single country. Not the United States, which invented nuclear technology. Not France, which generates 70% of its electricity from nuclear plants. Russia. And on January 11, 2026, Rosatom, Russia's state nuclear corporation, quietly notified 3 European utilities that delivery schedules for 2026 fuel shipments were under review pending resolution of payment processing complications. The notification was 4 sentences long. It affected fuel supplies for 18 reactors in 5 countries, and it marked the first time since the Cold War that nuclear fuel has been explicitly linked to geopolitical pressure. This is not an energy weapon. This is the energy weapon. The one Russia has held in reserve while the world focused on gas. Here's what they're not telling you. The nuclear fuel supply chain is the most concentrated critical infrastructure in the global energy system, and almost no one outside the industry understands why. Uranium is relatively abundant. It's mined in Kazakhstan, Australia, Canada, Namibia, and a dozen other countries. The raw material is not the bottleneck. The bottleneck is enrichment, the process of increasing the concentration of uranium-235 from 0.7% in natural uranium to 3 to 5% for reactor fuel, or 20% plus for advanced reactor designs. Enrichment requires centrifuges, tens of thousands of them, spinning at 50,000 revolutions per minute for months, gradually separating heavier U-238 atoms from lighter U-235 atoms through imperceptible mass differences. The technology is extraordinarily precise, extraordinarily capital-intensive, and extraordinarily concentrated. Russia operates approximately 46% of global enrichment capacity through Rosatom subsidiary Tenex. Urenco, a European consortium based in the UK, Germany, and the Netherlands, operates about 30%. The United States operates 12%. China operates 8%. France operates 4%. No other country has meaningful commercial capacity. The capacity numbers overstate Western independence because they ignore what's actually being used. Russia's enrichment facilities operate at 95% utilization. Western facilities operate at 60 to 70% utilization. The gap exists because Russian enrichment is 30 to 40% cheaper than Western alternatives, a cost advantage built on Soviet-era infrastructure, state subsidies, and electricity prices that don't reflect market rates. At 2:30 p.m. Vienna time on January 8, 2026, the International Atomic Energy Agency published its quarterly nuclear fuel market report. The report noted that global enrichment services remain adequate to meet demand, a technically accurate statement that obscures the concentration risk. Adequate supply doesn't mean diversified supply. It means supply exists if everything continues functioning as it has. The question no one in official positions will answer: what happens when it doesn't? This is where the lie becomes unsustainable. Western nuclear utilities have maintained Russian fuel relationships throughout 3 years of war, sanctions, and escalating rhetoric. The relationships continue because the alternatives don't exist at the required scale, quality, and price. A nuclear fuel contract isn't like a gas contract. Gas can be sourced from different suppliers with minimal technical adjustment. A molecule of methane is a molecule of methane regardless of origin. Nuclear fuel is reactor-specific. The assemblies must match exact dimensional specifications, metallurgical requirements, and neutronic characteristics for each reactor design. A fuel assembly manufactured for a Westinghouse AP1000 will not fit in a Russian VVER1000, and vice versa. Approximately 78 reactors worldwide are Russian-designed VVERs, including 18 in the European Union. These reactors can only use fuel manufactured to Russian specifications. Until 2022, That meant fuel manufactured by Tvel, Rosatom's fuel fabrication subsidiary, using Russian-enriched uranium. There was no alternative because no one built one. Westinghouse has spent 3 years developing VVER-compatible fuel assemblies for Ukrainian reactors, a crash program funded by the U.S. Department of Energy and accelerated by wartime necessity. The first Westinghouse assemblies entered service at Ukraine's Rivne plant in 2024. The results were mixed. 2 assemblies experienced premature failure, requiring early removal, and overall performance remained below Russian fuel benchmarks. The qualification process for new nuclear fuel takes 5 to 7 years under normal circumstances. Westinghouse has compressed this to 2 to 3 years by accepting higher risk, but higher risk in nuclear fuel means the possibility of fuel rod failures that release radioactivity into reactor coolant systems. No Western utility outside Ukraine has agreed to accept this risk. They continue buying Russian fuel because Russian fuel works. At 7:45 a.m. Prague time on January 9, 2026, ČEZ, the Czech national utility, confirmed that its Temelín and Dukovany nuclear plants would receive Russian fuel shipments for 2026, as contracted. The confirmation came after a week of silence following Rosatom's delivery review notification. The Czech government, which has been among the most hawkish EU members on Russia sanctions, was notably quiet about how the payment processing complications were resolved. This is the quiet accommodation that occurs beneath the loud rhetoric. Governments condemn Russia in press conferences and approve fuel payments in back offices, because the alternative is reactor shutdowns that no electricity grid can absorb. When institutions do this, they're not managing risk, they're containing disaster. The scenario that nuclear security analysts have modeled but politicians won't discuss is simultaneous Russian supply disruption across multiple fuel cycle stages. Stage 1. Enrichment services. Russia could simply stop accepting new contracts for uranium enrichment, forcing Western utilities to compete for limited Urenco and U.S. capacity. Current spare capacity could absorb perhaps 30% of Russian volumes. The remaining 70% would become a shortage within 18 to 24 months as existing inventories deplete. Stage 2. Fuel fabrication. Russia could halt exports of finished fuel assemblies to VVER operators, immediately affecting 78 reactors with no near-term alternative supply. The affected reactors would operate until their current fuel cycles complete, typically 12 to 18 months, then face shutdown. Stage 3. Conversion services. Before enrichment, uranium must be converted from yellowcake, U3O8, to uranium hexafluoride, UF6. Russia operates 27% of global conversion capacity. Disruption here would bottleneck the entire supply chain, regardless of downstream enrichment availability. The Nuclear Energy Institute, the U.S. industry's lobbying arm, published an internal assessment in November 2025, modeling simultaneous disruption across all 3 stages. The assessment, portions of which were reported by Energy Intelligence, concluded that global reactor fleet availability would decline by 15 to 20% within 2 years, with disproportionate impact on European utilities dependent on Russian-designed reactors. 15 to 20% of global nuclear generation represents approximately 400 terawatt-hours annually, equivalent to the entire electricity consumption of France. Replacing that generation with fossil fuels would require 80 million tons of additional coal, or 60 billion cubic meters of additional gas, neither of which is available on the timeline that reactor shutdowns would create. The scenario has been modeled. The countermeasures have not been funded. Less than 18 months of fuel inventory exists at most Western reactors, the standard operating buffer that utilities maintain for supply chain continuity. If Russia announced tomorrow that all Western fuel contracts were suspended, the clock would start immediately. 18 months to develop alternative supply or face cascading shutdowns across the nuclear fleet. On January 14, 2026, the U.S. Department of Energy announced $2.7 billion in funding for domestic uranium enrichment expansion, the first significant federal investment in enrichment capacity since the Cold War. The announcement was framed as energy security enhancement. It was not framed as crisis response, because framing it that way would acknowledge the crisis exists. The funding will support 2 projects, Centrus Energy's demonstration facility in Ohio and a proposed new plant by Urenco in New Mexico. Combined capacity, if both projects succeed, would reach 15 million SWU annually by 2030, significant, but still less than half of Russia's current capacity. The gap will not close before the vulnerability window does. While one side scrambles, the other side waits. Russia's nuclear leverage differs from its gas leverage in a critical respect. It hasn't been used. The January delivery notification was pressure, not cutoff. The fuel is still flowing. The weapon remains holstered. The restraint is strategic. Russia earns approximately $4 billion annually from nuclear fuel exports, significant revenue, but not enough to justify the geopolitical cost of weaponization unless the circumstances demand it. The gas weapon was deployed because Europe was actively cutting ties anyway. There was nothing to lose. The nuclear weapon remains available because the relationships continue. There is something to preserve. But available means the leverage exists, and leverage that exists can be deployed when circumstances change. The scenarios where deployment becomes attractive are not difficult to imagine. NATO expansion of military support to Ukraine beyond current levels. Western seizure of the $300 billion in frozen Russian assets for Ukraine reconstruction. Direct Western military intervention in a Russian-perceived sphere of influence. Any escalation significant enough to warrant response beyond conventional means. Russia has demonstrated willingness to use energy as a weapon. It has demonstrated ability to sustain economic warfare. The nuclear fuel lever exists and has been publicly identified. The only remaining question is the trigger. Rosatom's corporate strategy documents, obtained by the Financial Times in December 2025, include scenario planning for adverse market access conditions, corporate language for sanctions or counter-sanctions. The scenarios show Rosatom redirecting enrichment capacity to domestic use, Chinese contracts, and non-Western emerging markets. The documents note that revenue impact of Western market exit would be offset within 36 months by Asian demand growth and defense sector prioritization. Russia has priced the cost of weaponization. The cost is acceptable under certain conditions. The West has not priced the cost of being weaponized against. The asymmetry is dangerous. The mathematics of the trap are now inescapable. The nuclear fuel dependency creates a vulnerability structure with no near-term exit. Exit path 1. Accelerate domestic enrichment. This is underway but insufficient. The $2.7 billion DOE funding represents perhaps 20% of what would be required to achieve genuine supply independence by 2030. Full independence would require $15 to $20 billion in capital investment, workforce development that takes a decade, and regulatory approvals that take 5 years under expedited processes. Exit path 2. Diversify to non-Russian foreign suppliers. Urenco and French capacity are already operating near maximum utilization. Chinese enrichment serves domestic demand and is not available for Western contracts due to export controls and strategic considerations. No new enrichment capacity exists outside Russia, China, and the Western Consortium. Exit path 3. Reduce nuclear generation to match available fuel supply. This option requires replacing nuclear generation with other sources, renewables that haven't been built, gas that's already in shortage, or coal that emissions commitments prohibit. The grid cannot accommodate 15 to 20% nuclear reduction without either blackouts or carbon policy reversal. The trap is that all three paths require time that doesn't exist and resources that haven't been allocated. The vulnerability is structural and cannot be resolved through policy announcements. Only physical infrastructure closes physical supply gaps, and infrastructure takes years to build. Russia's position is to preserve the option. As long as nuclear fuel flows, the weapon's credibility remains intact. As long as the weapon's credibility remains intact, it influences Western calculations even without being deployed. The threat is sufficient. Use would be wasteful. This is the logic of a reserved weapon, one that grows more valuable by remaining unused while the target remains unable to develop defenses. This is what a system looks like when the dependency was built over decades and the escape must be built in years. The informed are not waiting for official announcements to understand what's happening. Uranium spot prices have increased 180% since January 2022, reaching $107 per pound, the highest level since the Fukushima panic selling of 2007. The price reflects supply concentration risk that public discourse hasn't acknowledged. Commodity markets see what energy ministers won't say. Uranium mining equities have outperformed broad energy indices by 340% since the invasion. Cameco, Kazatomprom, and junior mining companies have seen valuations expand, not because uranium demand has surged, but because supply security has become uncertain. The market is pricing in scenarios where uranium at any price becomes preferable to uranium unavailable. Physical uranium funds, investment vehicles that hold actual uranium rather than futures contracts, have seen inflows of $2.1 billion since 2022. The funds remove material from commercial availability, creating tightness that amplifies price signals. Investors are accumulating physical uranium for the same reason investors accumulate physical gold: distrust that paper claims will convert to delivery when delivery matters. The premium for enriched uranium products over raw uranium has widened from historical averages of 40% to current levels of 65%, reflecting the enrichment bottleneck that determines actual fuel availability. The spread indicates where the real constraint exists. Mining can expand. Enrichment cannot, except through the concentrated facilities that create the vulnerability. Conversion services prices have tripled since 2022, with spot availability essentially non-existent. Utilities seeking conversion outside existing contracts are being quoted delivery dates in 2028. The entire fuel cycle is tightening simultaneously, with Russia controlling critical nodes at each stage. The question is not whether nuclear fuel represents a Russian pressure lever. The question is, who understands that lever's significance before it gets pulled? A ceramic pellet the size of a pencil eraser. 7 grams of compressed uranium dioxide. The energy equivalent of 149 gallons of oil, manufactured in facilities that Russia dominates to a degree that makes gas dependency look diversified. This is not the energy weapon Russia has used. This is the energy weapon Russia has kept in reserve, maintained through continued supply to demonstrate reliability, while the underlying dependency deepens and the alternatives fail to materialize. Physics doesn't negotiate. Centrifuges don't spin faster because politicians demand supply security. And reality, eventually, asserts itself over every energy strategy that assumed critical supply chains would remain available because they always had been. The divergence between nuclear energy's green reputation and nuclear fuel's concentrated supply chain has never been wider. What happens next is not prediction. It's 44% of global enrichment capacity controlled by a nation at war with the West's stated values, waiting to see if the West's actions ever match its rhetoric.